In this video we will discuss about one more approach of making hydrogel. So in this approach the monomer that is used are this acrylate and acrylic acid, and the crosslinker that this approach is used is the same as that of previous approach, that is Bisacrylamide. So how this process of making polyacrylamide co-acrylic acid hydrogel goes, we will discuss that thing in this video. So first we have a glass layer, glass surface or the cover slip that needs to be integrated or that needs to be activated with this 3 APTS or 3 trimethyloxysilyl propyl acrylate. So this silane group will react with this uh, cover slip to make it more functional, After that, this group of that is COOH will be able to interact with this acrylic that is present in the acrylic co-acrylic medium. The reaction is shown in this area in the middle bottom side, where we can see that when the radical reactions occurs, so this is the part from the polymer that can interact with this part which is on the functionalized cover slip, and this that is CH2C COR is basically comes from this side, that is COOH, that is COR and O. This R will be means H, and this can interact with this CH2, and these reactions will form like this: COR C CH2 and CH3, and CH2 will make a bond with this C carbon bonds, second carbons, and this will leads to the cross-linking of the functionalized cover slip with the hydrogels. And along with that, what will happen, there is a polymerization occurs of the acrylamide and acrylic acid, and this is the polymers that is formed, which is composed of both acrylamide and acrylic acid, and these polymers are cross-linked to each other with the help of bisacrylamide, similar that we have discussed in the previous video. And in this case also they will use APS and TEMED to initiate these free radicals reactions that can lead to the polymerization of this acrylamide and acrylic acid and the cross-linking with the help of bisacrylamide, and those initiation of free radical reactions will also cause cross-linking of this functionalized cover slip with this polymerized hydrogel. All these things will occur at the same time when the free radicals initiator has been triggered with the TEMED and APS reactions. And once this hydrogel is formed, then we need to functionalize this hydrogel so that the extracellular matrix proteins can be interact with these hydrogels. So in order to do this, we need to put a layer of this NHS, functionalized NHS, and in this case we will not use direct NHS, but we will use this coupling reactions of EDC and NHS. So in this case we will add EDC and NHS, and this EDC will first react with this acrylic acid part, that is ROOH, and that comes from this COOH. EDC will react with this acrylic part to form a unstable intermediate, and this unstable intermediate will react with NHS to form a semi-stable intermediate, and this semi-stable intermediate then later can be interact with the free amines group that are present in the extracellular matrix proteins, and thereby it will bind to this hydrogels through this semi-stable intermediate form, and this is the final binding of ECM with the hydrogels, or this semi-stable intermediate will occurs, and thereafter the hydrogel is ready for the cell culture, as it will be now populated with the desired acellular matrix protein. So this is how this polyacrylamide co-acrylic acid hydrogels is formed and functionalized. One thing we need to understand that during this binding of the ECM with the amine group, we need to make sure that it should occur as early as possible, as it is semi-stable intermediate form. If we keep the hydrogels in this state without interactions with the ECM, this will get disintegrate, and we need to do this coupling reactions of EDC and NHS before doing the ECM binding. So this is how this polyacrylamide co-acrylic acid based hydrogels method is being used. The method that we have discussed is being used to make this polyacrylamide co-acrylic acid based hydrogels. The advantage here is that this intermediate is more stable compared to the NHS intermediate that we have discussed in the previous video. That is this is stable only for few, like 1 or 2 hours, but this is stable for like few hours if kept at the appropriate conditions, that is at low pH and at 4 degree. And in order to keep it at low pH, people usually use these EDC NHS reactions in the MES buffer at around 4.5 pH. But when these acellular matrix are not, most of the acellular matrix are not stable in this MES buffer at low pH, so this binding of ECM to this semi-stable intermediate usually occurs at neutral pH, and this semi-stable intermediate is not stable at neutral pH. So we need to take into account we need to optimize the conditions so that we will have the optimum ECM binding to this hydrogels through the semi-stable intermediate form. So I hope you understood some of the differences between this polyacrylamide co-acrylic based hydrogel and what are its advantages compared to the previous method. So that's all for this video. If you want to understand more about this approach in detail, you can go through the references that has been provided in the description. Thank you for your time.